My name is Daniel Rieck. Welcome. I work in the CTO office at Red Hat, and I'll give an update on our AI strategy. Fairly high level to see where we're going, what are the use cases we're looking at. So overall, just to level set a little bit, I'll use AI as a shorthand for a whole bunch of concepts to simplify. We all understand that it's a pretty broad term, and it's a little bit buzzy right now. There are a whole bunch of concepts. Some of them we're talking about since 30 years that we are applying now primarily because we have the compute power to do things that people have dreamed of. To some degree because there was some rethink how you look at problems, some advance in the framing. So I'll talk about AI as a shorthand for the whole concept of big data analytics, machine learning, and cognitive systems. The basic framing is that AI at the stage we are right now represents probably the most fundamental transformation of industry across the board, all industries, since the Industrial Revolution. That sounds pretty big, but there is a fundamental change in how we interact with computers at the point where machines are actually learning things, right? So the big transformation is that repeatable tasks, if they have any probabilistic relationship between input and output, now can be handled instead of humans looking at data, understanding the data, and writing rules or writing programs. Machines can learn from that data based on the probabilistic relationship and then come out with correct outcomes at handling amount of data that humans simply can't handle. Right? So that is a qualitative deference to automation in the past, right? If you look at the Industrial Revolution, productivity of humans was increased, complexity was increased, also the challenges for humans was increased, but you could, in many cases, actually complexity of interaction was reduced, right? You went from being artful at something, understanding it, you went to pressing a button and then the machine did something and you could do more of it. We're now at the point where the machine does things. We don't actually understand anymore why the machine does things, but we can validate that it's correct. And it also can do it in some areas better than we can do. Everyone brings up the example of AlphaGo. It's a great example, right? Google had a machine that beat the best human player in the game of Go. And then was trained by humans in a supervised training model, and then wrote another model that self-trained to beat the first model that beat all the humans, right? So now we have machines that train themselves to beat humans. And a little joke I picked up at one of the conferences I went to, this from David Kieran at MIT Sloan, just the irony of that we have this thing, I'm not a robot. We have concepts, to have software that trains itself to say, I'm not a robot. Think about that a moment. It's not that hard, actually, but it means something on a philosophical level, right? So we see that as a fundamental transformation that goes beyond what we've done before, and it changes things. As I read that, for us, this is kind of in a continuation of transformation in the software industry. We really see this as the next big step. So right now we're somewhere between software is eating the world and cloud native, right? In a transformation for everyone. We're talking about digital transformation, and the next iteration is toward AI, where it's data rules the world, right? Data is the thing that matters for everything. There's a quote I like it from. It's attributed to Donald Knuth. It's from a book, Superintelligence by Nick Bostrom, that I can really recommend. It's a bit gloomy on the impacts and the risks with AI. There's some, an anecdote is that realistically, every AI that gets to human level general intelligence will attribute a high probability, greater than zero probability to living in a simulated world, right? Which is kind of funny, we don't know. for AI that's been trained with training data, that is very high probability that it's in a simulated world because it actually lived in a simulated world at a point. Right? Lived. That is a heavy term there. But Duncan basically made this joke, I attributed to him at least, and everything humans do that we need to think about, we got machines now that can do that. It's the things we don't think while doing that seem to be hard. That's a ironic twist. It's not 100% true, but it's a lot, right? The things that are analytical thinking that you consciously do, a lot of that we can automate. Subconscious and emotion, intuition. That's where we have a harder time right now. An interesting aspect of what's happening in AI is that it's very open source friendly. It's very interesting from a Red Hat point of view, and I guess from community and our customers' point of view. Right? We are an open source company, so that's really good. On the other side, there's a shadow side, the dark side of this, which is that data now becomes a proprietary differentiator, right? And that has some consequences because no amount of algorithmic sophistication can overcome a lack of data. Another quote from David Kieran. But it's very true. The base of AI, and in any meaning of that buzzword, is that you have a lot of data. There's a probabilistic relationship between input and output, and because you have so much data that you can train a model and to come, the next time it gets new data, come to the right conclusion about that data. If you don't have enough data to train on, you will not be able to train the model to come to the right conclusion because it wouldn't have enough basic. And the good side of that also is still a difference to like humans, right? We have certain things where like evolutionary, we got to a point where we can draw conclusions with very little data, right? So we have a little bit of an edge for some time there. We'll see if someone finds a way around that. So that's just some general framing. How what's going on. What do we see going on? Now, what does it mean from a Red Hat point of view? Right? From our view, there are like basically 5 pillars to AI, right? The 5 pillars of what I would call our AI strategy. The first one is pretty straightforward. We are an infrastructure platform company, and AI represents a workload. Right? Things we want to run on top of our platform, we want to enable that. The second one, I think is pretty straightforward, but most of you probably have thought about that. We all, like any business, we also want to apply AI to our internal processes, right? And when you say internal process, of course, we're doing all the same things in marketing and finance that everyone is doing. We're probably using the same tools that everyone is using, but we're also looking at applying AI to the internal engineering process, development, internal operations, CI/CD, and I'll explain a bit more what we mean by that. The next pillar is that AI also enables us to provide direct services to customers, right? Where we use it internally, you wouldn't know that we're using AI, right? We create Linux, and now we're using some AI in the process. But we also have an area where we're going to expose customers to services that are clearly AI-based. So you're interacting with an AI in one way or the other, and you know that, right? And I'll explain a bit more what it means. The fourth pillar is basically what we call intelligent apps, and that's where we enable our customers to do things with AI, use AI in your own business, right? All our customers at the end create software in one way or the other. We're all software companies because we saw earlier in the last step of the digital transformation, software aids the world. And so we want you to be able to write intelligent software, use AI in that concept. And then fundamentally, all of that is based on data as a foundation, because without data, there is no AI. So to dig a bit deeper, what does that mean? AI is a workload. Right? If you look at it, AI represents an interesting challenge. Right? It needs enablement from the hardware up, right? It's an interesting, like, if you look at business software, enterprise software, cloud, like performance wasn't like a key attribute anymore. Hardware was kind of, we virtualized that away and no one cares anymore. It's scale that matters, but not performance, and we trade off actually performance for scale and for elasticity and for density and virtualization, for portability. Now with AI, we are back to performance actually matters because it's very complex computation, it's very data intensive. So suddenly there's an actually direct business impact for everyone doing this from a performance point of view, and suddenly hardware matters, right? We have people talking about instruction sets and processor generations again, and obviously GPUs are like a key part of machine learning with tenfold improvements by moving things to GPUs. There is also an interesting trend that we see, and no surprise that we would say that, but it's honestly a trend I see, is that Kubernetes is establishing itself as kind of the default. Containers are becoming the default in the space. So most people who, at this time in age, who start in AI or have started writing software, most of the frameworks and higher level workflows we see are built around containers as a core concept in how you encapsulate your models, even how you sometimes archive your data, things like that. So it's very much built around that. Depending when people started or where they're coming from, they don't necessarily use the same container technology, or they're not necessarily using Kubernetes, right? If you started before Kubernetes 1, you might be on Mesos, or you might be on Docker Swarm or something like that. But we see a clear trend that people we talk to are already consolidating on Kubernetes, right? Even outside of like the Red Hat friendly world. And then, a lot of people are actually right now putting in their own version of Kubernetes. They are on their own version of the Docker runtime, and try to differentiate on that. While there's we see of course a consolidation in that space. Interestingly, a lot of the data science workflows, AI workflows, replicate general DevOps workflows. So it's very similar how software developers work. It's a different perspective on it with slightly different tools, but on the lowest level, you end up with very similar pipelines. Internally, we use OpenShift for that directly, right? Jupyter Hub through Jenkins pipelines and to containers, or OpenWhisk for APIs and to run the models. So that's interesting from our point of view, because we think OpenShift really fits well. We have like the aspects of RHEL for hardware enablement, and with OpenShift on top of that, that works really well here. We also think that observes that it's very loose and fast moving early on in the exploration of AI. When you get to a point where you actually put it in production, now business critical decisions are taken by machines automatically, on some level, right? It's interacting directly with your customers. It's trading. That's a use case that actually is in production today with a whole bunch of customers. And suddenly you have the same kind of requirements for stability of the environment, and you get a bit nervous with too creative use of container technology in Kubernetes and Linux libraries and kernels and that, and there's a strong move to consolidation, right? So we are committed to making that work, providing this enterprise stability for that use case through RHEL and OpenShift and storage product like Ceph. And we are working on things like creating auditability, right? How do I, when I go through my training workflow, have platform support for encapsulating your data with your model so that you can later reproduce what data you trained your model with if someone comes asking, right? In regulated industries, that's a big problem, because we can't explain, the models don't explain how they came to a conclusion, but what we can do to satisfy any kind of requirement to prove that we didn't cheat is to have the training data and the code together so we can show that and say, here's what we did. And even if we don't know, we don't understand anymore what it does at the end, and no one does. So then that's kind of where we are right now, working to make that work on this stack. We are working with a lot of ISV partners and hardware partners to ensure that that all the different levels of AI, workflows, tools, suites, individual services can work in this model. So there's a lot of enablement for containers, integration with the service catalog, things like that going on, to make sure that at the end you can consume this through the Kubernetes service catalog and plug together your AI workloads. We're also working with partners on the low level, and I want to ask Duncan Poole from Nvidia on the stage with me here for a moment, because we all know that like one of the most critical pieces is enabling the hardware. You have to stand with me here, otherwise you won't be. Otherwise you won't be in the video frame.
Okay, thank you, Daniel. Oh, Maya, you've got this.
Yeah, it's. You can also look over there.
You would think it would be a big screen because he has a laptop here, but this is what the slides are displayed on.
Otherwise, we would be looking back all the time, and yeah, it's.
All right.
Technology.
Well, I'll look a little bit over there because it's just easier to read. I was invited here by Red Hat. So my name is Duncan Poole. I'm the Director of Platform Alliances for Nvidia. And one of my partnerships is Red Hat. And so they like the message that Nvidia and Red Hat are increasingly collaborating on many projects in open source, but also we're trying to acknowledge some of the ongoing work that we've been doing. Well, longer. I've been at Nvidia for 10 years, and before I got there, there was already a lot of direct collaboration going on between Red Hat and my company. So they invited me to come up here and speak a little bit about that collaboration, just to give you a feeling for the relationship. So for me, Red Hat is a tier 1 partner, and our goal is to make sure that we can provide a tier 1 experience to users that want to install Red Hat on their system and use NVIDIA GPUs. There's a bunch of work to make it friendly. The work's not all done yet, but we're both rowing in the same direction to make this happen. More recently, we've managed to align on containers. NVIDIA has contributed a container plugin and helped contribute design ideas about health for things like accelerators. Basically, the framework that is Kubernetes also required some adjustment along with the NVIDIA plugin. And Red Hat and Google are key players in making sure that Kubernetes comes together well, so we're working with them on that. Also with Red Hat, since 2012, we've been working on heterogeneous memory management in the Linux kernel, in the Linux memory manager. And basically what this is if you have a device that has its own memory that it manages itself, how can you make malloc work between the device and the host in such a way that the person that's trying to program the device doesn't have to always think about where his memory is. And then finally, other open source projects like the GNU compiler. And I think actually this speaks better in the next slide. So what we've done lately is created RPM repos for our drivers, our CUDA compute driver, and all of the CUDA tools. You can do a yum install CUDA now after you've enabled the repo, which not everybody knows you can do. So that's a nice feature. NVIDIA has also worked with CUDA to host the most recent versions of GCC and LLVM and compilers for power and other things. So there's an Intel. There's a lot more variations for when you build an application to target the device that has to run on the device. It also has a host component, and there people have their preferred compilers. So we're trying to support and track those.
And I think, if I understand right, like the path is towards like being able to have a common code compilation model across both, that you have code that.
Yes, there's several ways to do that. So we have CUDA, which is a syntax that's added to C that you stick chevrons in, and it describes the parallel region and what you want to do. That's probably what everybody mostly knows. But there's also models like with OpenMP 4.5 and with OpenACC, where you just put a pragma around your block of code, and the code is then parallelized by the compiler and run on the GPU. To give you a feeling for this, the modern Volta, even without the tensor cores that are on it for AI, to keep it fed, you've got to have about 150,000 worth of things of work to do at any given instant in order to keep it fed. So the programming model is extremely parallel. So anyway, so packaging, new host compiler options on Kubernetes, working together on production-grade orchestration. There was a benchmark that was recently a collaboration between HP and Red Hat and ourselves. This is the Stack benchmark. It's a financial services benchmark. Runs on 8 GPUs on an Nvidia server. And in fact, they did 2 runs. One was sort of a native run, and then one was done within containers, just to prove that we could do it. So, so we're trying to kind of work together in different industries to show what we can do together. vGPU, that's demonstrated downstairs here at the Red Hat booth as an Nvidia pod. And this is basically a virtualized GPU where you're showing both compute and graphics workloads that are able to run in that environment. So feel free to come down and see that. And then finally, other open source projects. So GCC, there's an effort to teach GCC how to emit code that can run directly on the Nvidia device. So that's the drivers for that project in GCC are Red Hat employees, and we're working with them on that. And then HMM, the driver for that project is also a Red Hat employee. And so, basically, we look to Red Hat to supply us with a lot of the needed stewardship to try and move these features into these open source projects. Okay.
Well, thanks a lot.
You're welcome.
And we're very excited, about the progress we are making there, because at the end, we want to position ourselves in AI. Nvidia is very much the to-go place for hardware acceleration, and if we get that into the Red Hat stack, then the customers win, right?
Awesome.
So that is one of the most exciting things, and what we're trying to get to next. So obviously OpenShift is, as I said, the focus, the center of gravity for us here. So right now we have this in tech preview in 3.9, and there's a blog describing how to try it, and then stay tuned for future announcements. I can't make roadmap announcements, but we have proven that you can do it today, so we'll go forward from here. So let's go to the next pillar. So this was the enablement, AI as a workload for our platforms, from Ceph, storage, RHEL, OpenShift up. The next area where we're doing AI is applying it in our core business. And really, I'm quoting a co-worker of mine, Uli Draper. Really what this means, I mean, that we try to move from human-derived manual rules and heuristics to learned models in both the development process, but also in the code itself, like things the machine does traditionally, where you traditionally set static things, hard code into code. We are trying to establish learned models there. And I apologize for the desert of text. I'm not a very graphical person, as you can guess from this. So the way we look at that is complexity in modern software stack systems is growing, right? In every aspect of it. The clustered cloud-native applications running on a Kubernetes cluster are really hard. They produce a huge amount of data. They make it hard to trace. The process to create them are complex. So we're trying to augment our human engineers and developers, testers, with machines in processing these large amounts of data, right? And I think most of us who have worked with CI know the flake problem, right? You have a test that fails, and next time the job runs, it's green again. So it was a flake, right? It's not really a problem. It was some thing that happened and won't happen again. Often, there are actually serious problems hidden in there. They're just complex, race conditions or dependencies on other services, timeouts, the environment. It might just be your test environment, but still things you actually want to know. But you will not know if human testers look at it, because they can't process the amount of data needed to process to understand. If something only happens in a full moon, right? It only happens in a full moon. How many test runs do you have that coincident with a full moon? Well, I'm not. Now it's called flake. Back in the days, I think we said cosmic radiation, right? That was the reason. Bit flipped, and it's not a real problem. So the idea is that we employ analytics and machine learning algorithms to make sense of this data and identify these things, right? And there are some things are like straightforward patterns, pattern recognition. Some things are clustering, for example. So if you look at the data and you have your tests, enough metadata on your data and your tests, you can identify, for example, clustering in a multidimensional space with flakes, and you will identify when there are many flakes that cluster on certain aspects of the data vectors you connect, and then it's very likely that that is not actually a flake, right? Because there is something happening that makes them show up in a cluster. That's pretty straightforward, and gives you insights in your code or the underlying infrastructure and in complex problems that otherwise you won't have. And at the end, often catches problems that are really hard to debug when they happen in production when the customer sees them. Right? So it's a simple example. There's some others where we are implementing AI in the operations part of our systems, right, to automate operations for the CI systems. We are harvesting non-failure data, right, which is another interesting problem. In QE, you kind of have a pass-fail, but you're not harvesting often deep insights from things that actually worked. But that can be extremely interesting because, for example, I can aggregate the data and then predict before I actually run the test whether something will work or not, because I have data on things that worked and things that didn't work. If I have enough data on that, then there are predictions I can draw from that. It's a little bit like a weather report, but it's still better than not knowing, and you can take out some issues before you even run the test. Makes you faster. And as I said, the idea is that we are basically pairing humans with machines here, give humans better information, automate the churn, the things that for humans are a waste of time because they're always the same, and we try to get machines to do them for the humans under supervision. But in a way, look at AI not just as a tool, but rather treat the AI as a team member. Right? So there's a presentation later, and I have a link to that at the end, called Cyborg Teams. So we mean that in a way, literally, look at it as you junior team members we train. Right? Obviously, they're very special team members in very narrow areas, but that goes beyond traditional tooling. And we're trying to get that. We're doing this inside Red Hat. We are pushing this into open source projects. Right? So all of this goes upstream to get to better quality, better scale in the software we provide. The next area I mentioned is AI-powered products and services. So, as I said, the first part, you don't actually know that this is AI. It's just, you get better software. We have better data on our processes, and we can fix bugs faster. When we go to AI-powered services and products, we look at how can we make this available to you, right? And it expresses itself as AI being put into the platforms and the management stack to turn the platform into an intelligent platform, and then also adding guidance services that, based on aggregated knowledge, can tell you things about your environment, about your code, about the stacks you're building in your own software. And if you went to the first keynote on Tuesday, there was this demo with Red Hat Insights that looks at your configuration data, reports it to Red Hat, and then gets guidance back whether there are issues. Red Hat knows. And we had this example which tells you, oh, you are an outlier. 90% of our customers have this, for the same use case, have a different configuration and recommends to change the configuration to where the mainstream is. It's a pretty straightforward thing you can do with AI, outlier identification. And based on the aggregate experience of Red Hat and our customers and our communities, make a recommendation and create basically herd immunity, right? Because someone is going to run into an issue. Once the issue is identified and fixed, we learn from that, and we can tell all our other customers how to fix the issue even before they run into it, right? So we get to predictive support, predictive systems management. We combine that with AI capabilities in the platform and the management tools, to take localized decisions, give you the ability to have your own rules, things like that, and it becomes a very intelligent platform that gets to much better scale for operations beyond what individual, beyond what you can do manually with admins. In there, similar things in log aggregation and correlation, and then again, just on your log stream, look for anomalies, right? Look for outliers, look for things that are not supposed to happen. That gives you a better operational environment and makes your admins much more effective. So this is basically the extended version of what we're doing internally with the additional aggregation of knowledge. Another aspect, another example here is OpenShift.io, which is our hosted developer toolchain. In there, for example, is a guidance service that when you write your POM file will tell you about combinations that make sense or make no sense, that have failed in the past. So you don't have to find out yourself in CI that this version of a library will not work with this other version of a library because they're incompatible. Right? We already know that because we have run it, or we have a report from other customers. So it tells you that, or it can tell you whether you're an outlier. Right? You're the only one using this combination of a stack. Everyone else is on this other stack. Right? So give you that kind of information at hand. And that's possible basically because we can use AI to process this large amount of data, and then ultimately, for certain, the idea is to get to like a self-driving cluster, right? And we think that if you have self-driving cars, the least is to have a self-driving cluster in that car. Right? These cars are basically driving data centers. Not that I'm saying we're doing cars, but the self-driving cluster would be a nice thing to make, basically allow us to focus on the higher level functions and automate the infrastructure to a degree that you don't have to worry about it. The next pillar I want to go into is intelligent application. I said it's where we allow you to do things. So right now we already have a whole bunch of tools and products that are useful in an AI space. A lot of data-related products, decision-making products, like OptoPlanner, which is a constrained resolution product, JBoss Fuse for data integration. So we're positioning these things on top of OpenShift and enabling them for AI use cases. We also, in some of these, we're going to integrate AI. So decision-making, BXMS already has some AI plugins, decision tree models and things like that, and that's going to be expanded, obviously, which helps a lot to give you services that can do AI. And we're working with a broad ISV ecosystem here as well, trying to get ISVs to, on a standard platform, OpenShift, provide the ability through a simple interface like the service catalog, have operators for that automate the operation. And, by that, give you a very easy-to-use environment to use AI, make that commoditize AI for our customers. So a little bit more philosophical. I said data is the foundation, right? So for us, that, to some degree means like we want to expand like the trust relation we have around software to the operational data and development data. And we're doing that today. Every time you call support, you submit a SOS report, right? We're already trusting us with information about your production systems, your operations, and we use that data to service you, to tell you how to fix issues. We can also learn from the data. We have this project called Red Hat Insights, which runs basically it's like a SOS report, but an ongoing base, but more lightweight. But basically, it reports a system configuration, and then you get guidance based on the system configuration. And we expand that in OpenShift.io into coding, right? You write your code right now in a hosted J environment, but you write your code, you write your POM file, and while you write your POM file, it tells you, oh, this is a bad idea because it has failed for other people. And we're going to expand that into, for example, we're demoing in our booth, expand that to the combinatorics of like Python modules you use. Right? No one can, right now in the most common language repositories upstream, I think it's a total of about 1 million individual Python, C#, Perl, probably not many NPM packages. It's an exponential growth. No one can package all of them in RPMs, right? And no one would benefit from them. Most Python developers want to use them in the native format. So we're working on making that more usable. And again, you can use the same model. We can maybe not package them for you, but we can tell you whether there are problems we have seen with them, right? A specific combination of this version of the CUDA stack with that version of TensorFlow, with this specific other Python module because some symbol changed somewhere in that stack. We can tell you that we have seen that already, and so you're warned and you can act before it happens. We can probably recommend even a solution in many areas. This includes watching upstream repositories, gathering data from customer systems with the appropriate firewalling, right? Data flows from the community down. Obviously, customer data doesn't flow to the community up. So that's a big deal for us, right? Because we're expanding some degree to data from code, right? But we're in a world where the code depends on the data, right? The code is meaningless without the data in many cases, or unhandleable. So we want to expand into metadata on the code and learning from that. We also think that we need to have a discussion about like open data, right? What does it mean, if you do open source software, you have AI models and you have data? How can we facilitate a culture where there is, for example, training data available for a lot of things to keep things open? Right? So we will see how we make progress on that. We are right now working in a bunch of communities to basically create a common model for a data hub to enable communities to aggregate the data and use AI in the upstream communities. That's the first step on this journey, which today is very fragmented, right? Some projects have their things, many don't. So that's our view on AI. Quick recap. So, from our point of view, AI is one of the most important workloads. It's incredibly strategic for us. Everyone has to do it. It's a game changer. So, we know it ourselves because we've seen some of the effects of it in our own business. So, we will enable our customers to operate AI on our platforms, right? That's just the table stakes, and I think with the combination, Ceph as an object store, RHEL as the operating system, OpenShift as the application platform, and some of our middleware tools in our ecosystem, we are probably the most complete offering outside of the public cloud right now. The partners at the end are the most important thing here, right? Because Red Hat is not planning to become a general purpose like data science company. So you'll see us with partners, with some, like, you know, we're showing some IoT examples with Cloudera, for example, downstairs. We have some other data science companies on the floor, and you'll see more of that going forward. So that's the presentation. We have probably a little bit of time for questions. I wanted to recommend some other presentations in the second half of the summit. Unfortunately, two of them conflict. So the Cyborg Teams is about how to use bots in your CI DevOps model. The intelligent application of OpenShift is about, you know, how to use OpenShift. So the Cyborg Teams is for developers, you know, to interact, and the intelligent application is how to build an intelligent application. So the two different, it's more data science centric, not developer centric. And the others are tomorrow, so, and don't conflict.